First step is to center the cylinder to the spindle of the Bridgeport, and it's kind of neat thing we built here. All I'm going to do is drop that in, lock that cylinder. I'm going to lock this. Now I'm going to go ahead and clamp it. This is a rough setting. It's going to get me very close. After we clamp it, I'm going to lock my table. The next thing we're going to do is put a dial indicator in here and get it perfect. I clamp my cylinder down, threw my indicator in. The alignment fixture that we have, it's accurate within about 2 thousandths, but again, because we want to keep everything concentric with each other, this takes just a couple extra minutes. So I put a dial indicator in, and I just sweep the sides of the cylinder, and I have this dialed right in. The next thing we're going to do is we're going to cut out the top of this cylinder for this flange. The original sleeve that's in here is not smooth like this. It's got all kinds of bumps and divots on it, and then they cast the cylinder around the sleeve, and that keeps it in position. This flange is going to keep this, it's going to assist it from moving up and down. It's not going to do anything as far as spinning goes. That's up to me as far as the interference fit, and that's why it's so important. That's why we work to 4 thousandths, nothing less than that. I'll buy somebody a cylinder before I'll let anything go out of here with any less of a press than that. So we measure this, 2.899 rounded out to 2.9. We know that this is 2 3/4, so we're going to open this up about 150 thousandths, and we're also going to consider the depth. It's 1/8, 0.125. So I'm going to come in with my boring bar, touch the top, dial off 1/8 of an inch. That'll set my depth, and just start taking progressive cuts out until I achieve the dimension I want here, which is as well is 4 thousandths smaller than the outside diameter of that flange. We've got our cylinder locked, clamped, centered. I put my boring head in here. As we recorded the depth of the flange, this needs to be recessed 1/8 of an inch deep. This is a stop. A lot of you guys, I'm not going to bore you on how to work a Bridgeport, I'm sure you all know anyway, but this stop, this is a Fowler gauge pin. We know we have to go in 1/8, so I'm going to put this gauge pin in here, bring this up, so it gets tight. I've got my spindle locked. Bring the lock in. And that's going to get me very close. It's probably not going to be deep enough, but we can always go in a little bit more. We set up our first cut with the dial on the boring head. As I turn this basically just moves out, and we're going to take a bigger bite. We're going to take our first cut. Table's locked. Next step is just to dial out another cut. I'm going to take probably about 30 on this. And we'll just continue until we get the counter bore for the flange on the sleeve finished. Check my outside diameter. Outside diameter is fine. The next thing I do is just take a little piece of sandpaper and knock this burr off the top, and then take my depth mic and check my depth. We're right on the money. Next thing we're going to do is hone the inside out so it's the perfect finish and the perfect size to drop the sleeve in. I've got my cylinder in my hone, and what I'm going to do is remove the last 2 thousandths with 280 grit stones. We've got our cylinder honed to the spec, and again I'm running a 4 thousandths interference fit. If you really look in and do the research and start digging into LA Sleeve and their recommended procedures, they actually recommend a 2 to 3 for cast iron to cast iron. I've done many of these sleeves and blasters, and this cast is so thin, I just feel a lot better with 4,000s. I don't want this thing twisting around. I've sunk many of them like that and never had a problem. Usually for aluminum, your interference fit is going to be 4,000s. Cast iron, 2 to 3. What we did is we went ahead and we cleaned everything. This stuff, and I can't stress this enough, this has to be immaculate. If you have one little piece of dirt that gets between this cylinder and this sleeve, when you're dropping it in during the thermal expansion process, it's going to stop it. You're going to have to take it out. You're going to have all kinds of problems, all kinds of headaches. So cleanliness is optimum on this stuff. We shot this with brake cleaner, put it in kerosene, shot it with brake cleaner, and then I took WD-40 on a rag, wiped it in this direction, got all the crap out of it, shot it again with carb cleaner, and I did the whole process again. When I start coming out with white rags, I know that this surface is immaculate. I did the same thing with this. This sleeve has been deburred. We were very careful not to take anything off the outside diameter of it, but really paid attention to all of these burrs that were on this. They weren't big, but they were there. And again, when you're running a 4,000th interference fit, that may stop you from dropping the sleeve. The next part of this process is going to be to thermally expand this cylinder approximately 6,000ths bigger than the outside diameter of the sleeve. If you remember correctly, the sleeve was 2 inches, 750 thousandths. This is 4 thousandths smaller. I want this hole to be 6 thousandths bigger than this. There is no press involved in this procedure. This is going to be heated up till it's expanded. During the heating process, I'll check it continuously with a bore gauge until I see the figure that I want in here, which is 6 thousandths clearance over this sleeve. And then we're going to go ahead and drop the sleeve in. You have approximately, it's going to fall right in there, you have approximately 5 seconds tops to line this up, and that's on a good day. This is in a climate controlled atmosphere. 68 degrees is preferred. Anything warmer, anything cooler, things aren't going to work the way that they're supposed to. We're going to get this to between 350 and 450 degrees. I really don't want to get it any hotter than 450, so we'll check it at the same time that we're heating it. This process, I'm not going to film it. It takes way too long. You can do this in a household oven. I don't recommend it. Laboratory ovens work great for this. We got our sleeve in successfully. It's lined up to my satisfaction. When they cut these ports small, and they do it for a reason. If there's a little bit of misalignment in a sleeve, you're going to be able, you should be grinding this anyway when you're done. You're going to be able to fix whatever misalignment, and you're going to have to come in here and grind it anyway. Here's the bad news. A lot of companies out there, when they put a sleeve in, the next thing they're going to do is they're going to bore this cylinder and they're going to send it back to you. They are not going to touch these ports. We don't do that here. I'm going to match every single one of these ports, every single dimension to stock dimensions, and that's how we send it back. This cylinder, as you can see, has got some kind of home porting going on in here. Actually, not a bad job. And I'll go ahead and I'm going to blend all of this. If you leave it like it is, you're going to lose a lot of performance. And the big thing, the boost port here isn't even close. This has probably got to go up 3 millimeters, and that's a ton of performance right there. And again, OConnor Racing, we're going to match this up and port this out, and you're going to maintain all of your factory performance.